Okay, so now we need to look at concavity. So we need to take our second derivative. Our first derivative is here. Again, that comes from right before we set numerator and denominator equal to 0. That is our first derivative in its most simplified form. So for the second derivative, we're going to do the quotient rule again because we do have a variable divided by a variable. So we'll have 6x squared minus 120x and then x minus 10 squared. This will go to 12x minus 120, and then here we'll need the general power rule, bring down the 2, keep the base, subtract 1, and then technically you multiply by the derivative of the inner function, but the inner function's derivative, x would just be 1, negative 10 would be 0. So you don't really need to write that times 1 there. All right, so what we're going to do is we're going to plug into the quotient rule. That is now going to be our second derivative. So we have parentheses needed because we have two terms here. So 12x minus 120 and then times the x minus 10 squared minus, and then this diagonal, 6x squared minus 120x times 2 times x minus 10, and then all over the bottom squared. Okay, now the easiest thing to do here, and this is going to be a little intense at times, but the easiest thing to do is to remove your parentheses, or you look at this and you say, I have the squared power. I don't want to sit there and FOIL it out. So another option is the GCF. Now, for the GCF, what you're going to do is you're going to look at the first diagonal and you're going to look at the second diagonal. And you're going to say what is common to those two diagonals. Okay, so let's take this one step further. When you look at both of these diagonals, you see that you have this x minus 10, x minus 10. Here it's raised to the first power, there it's raised to the second power. So the GCF would be x minus 10 to the smaller power of the first power. Now, there is another GCF. You could also look at the GCF between these two factors. Most students, though, don't do that. Most students kind of just see the parentheses and that's what they focus on their GCF as. So what I'm going to do is I'm going to just run through this saying, well, that's all I see. Let's just say hypothetically all I see is the x minus 10. All right, so then what I would do is I would say, okay, I'm going to take out from this first box, I'm still going to have the 12x minus 120. And then if I take out one of those factors of the x minus 10 from the 2, I will just have 1 left over. Now, this is technically me doing this. I'm dividing by that GCF of x minus 10 to the first, and then one of those factors cancels, and I'm just left with an x minus 10 to the first. All right, then the same thing would go for the second term. I would divide the second term by x minus 10, the GCF that I'm proposing, and then that x minus 10 would cross out. So I would end up with just 6x squared minus 120x times 2. Now, if I go this route of factoring out the GCF, once I factor out the GCF, then inside of these parentheses, I am going to remove parentheses. Now, keep in mind, I still have the denominator. I'm going to tack that in at the end. Right now, I'm just going to focus in on the numerator. So again, this is numerator only that I'm focusing in on. So I'm going to have x minus 10. And then here, for this first term, I'm going to need to FOIL this out. So again, I'm going to look at this and say that I have a 12x for my first times x. So that's going to give us a 12x squared. Then my outer term will be a 12x times negative 10. That will give us a negative 120x. And then my inner term will be a negative 120x. And then my last two will be a negative 120 times negative 10, giving us a positive 1200. Then we have a minus, and you'll notice here I have a 2, that one term that is tacked at the end. Remember, if I have a one term, I'd like to put that in the front so that it's easier to distribute. So I'm just going to shuffle this little 2 to the front of this term so that I can easily distribute the 2 and the negative at the same time. So that will become a negative 12x squared, and then the negative 2 times the negative 120 will give us a plus 240x. All right, so I remove the parentheses inside of that leftover quantity, and then I combine my like terms. So the good thing is I see a 12x squared here and a negative 12x squared. Those will cancel out. I also have a negative 120x, negative 120x, and a 240x. Those are just going to go to 0 because I'm going to take negative 120 minus 120 plus 240. That goes to 0. So those also cancel out. And then I'm just left with my x minus 10 that's still there times the 1200. Okay, and so of course that can be written as just 1200 times x minus 10. And then now I'm going to put that over my bottom squared, my x minus 10 squared. And that is my second derivative. So we kind of do like this long factor out the GCF process. And then once we have that GCF factored out, then we put back in that bottom squared. And then now that I have my one, and let me just recap. What we did is we could have removed the parentheses. I could have FOILed all this, but instead I said, is there a GCF? I remember that the GCF is the smallest or the smaller exponent. So between 2 and 1, it will just be 1. I took out that GCF and then I divided each of those polynomials by the GCF to get what was left over. Then I removed those parentheses and then combined like terms. Now that I have my second derivative in one fraction form, I can now set the numerator equal to 0 and the denominator equal to 0. Solving this equation, I will just divide by 1200, or I could set factors equal to 0 too. That will give us x minus 10 is equal to 0, which gives us x is equal to 10. And then over here, again, take the square root of both sides, get x minus 10 is equal to 0, and we get x is equal to 10. Now, because we are being asked for concavity, we would then draw our derivative number line with the 10. Now, technically 10 is actually a domain restriction. It's not where the second derivative is defined, but if you don't pay attention to that, if you just say, okay, I got 10, I'm going to put down 10, then you would have to plug in a number to the left and to the right of 10. And we would be plugging into that second derivative, which is the 1200 times x minus 10 over x minus 10 squared. Now, if you're sitting there and you're saying, can't I simplify that further? You are 100% correct. And honestly, that's probably what we should have done up here. A lot of times students don't do that, so I didn't want to make a big deal of it. But you can simplify this because you have an x minus 10 to the first and an x minus 10 squared. So if you cancel out one of those factors, your second derivative really looks like 1200 over x minus 10. That's really your most simplified second derivative. And it's really just because you have x to the first over x squared, that would reduce to an x to the first. So that's the same idea that we're using here when we subtract those exponents. So if I plug in a number to the left of 10, so let's say I plug in negative 1, I have 1200 over negative 1 minus 10. That gives us a positive over a negative. So that will give us a negative. So that negative tells us, because we're talking about the second derivative, it tells us that it's concave down. Meanwhile, to the right of 10, let's say I plug in 20. And so if I plug in 20, I will have 1200 over 20 minus 10, and that will give us a positive over a positive. So that positive overall tells us that it is concave up on that interval. Okay. So what we would then say is we would say it's concave down on negative infinity to 10, concave up on 10 to infinity. And the inflection point is a little bit of a challenge here. The inflection point, it looks like there's an inflection point due to the fact that it's changing signs. However, there is not, and that is because of the domain restriction. And you would see that very, very quickly as soon as you plug in 10, you would plug in 10 into that original function. And when you plug in 10 to the original function, you'll see you have a 10 minus 10 in the denominator. So that is the number over 0. That is undefined. And so because that is undefined, you would need to say that there is no inflection point.